Hello, everyone. It's me, Miss Kirkley, one of your favorite math teachers here at the 7th and 8th grade academy. And if I'm not, I will be by the end of these YouTube videos. So today we're talking about comparing rational numbers and equal representations and what those all look like. So today we're going to be focusing on comparing our numbers and what symbols we use to do that. So what I will tell you is, first and foremost, mathematicians are lazy. So instead of saying 1/2 is greater than 1/3, we get really lazy about writing greater than. And so we decided to come up with a system of symbols that we all agreed upon to use. Now it is your turn to learn those symbols so we can use them together. First things first is we have our less than symbol. It looks like a slanted L. And because of that, that is our less than symbol. Greater than is the opposite. Equal to is just an equal sign. Sometimes we're going to see this symbol that has a line underneath it, and that line underneath it is less than or equal to, greater than or equal to. This will be more important later when we are talking about graphing inequalities, but I just wanted to name those symbols now because these are also going to be seen in your time using our middle school math. So here we're going to quickly discuss these three sets, and we're going to either name if one is less, greater than, or equal to with the way that they're laid out. The first thing I will tell you to do is that fractions sometimes can be really deceiving when we're talking about how big or small a fraction is. So what I will always tell you to do is turn our fractions into decimals. We've done this a lot of times where we read the piece of paper top to bottom where that fraction bar is just division. So this is like 1 divided by 2. And when I do 1 divided by 2, that gives me 0.5. Decimals do not lie to us. They are the secrets we tell at our slumber parties. So we have 1 divided by 3, and that's going to give us 0.3 repeating. Remember I said that bar just means repeating on and on. Just like Miss Kirkley thinks Kendrick Lamar drops tons of bars, those bars keep going and going and going because Kendrick Lamar does not stop dropping hot bars. So that means that there's a bar on top of the numbers that repeat forever. So with that being said, 0.5 or 0.3, even though this is going to continue on forever, 3 is always going to be less than 5. So that means this number is bigger. So 1/2 is greater than 1/3. Let's try it here. So I have 1/5 and 3/6. I'm going to change this to a decimal. So 1/5, 1 divided by 5. Remember top to bottom, this is division, is going to give us 0.2. And then I have 3/6. 3 divided by 6 is going to give me 0.5. I know 0.5 is always going to be bigger, so I'm going to write less than because 1/5 is less than 3/6. Notice how this is like reading a sentence. It should be like reading a sentence. So if I say something and I'm reading it across left to right and it does not sound right, it is not the correct symbol. So if I know 1/2 is greater than 1/3, but I'm like, well, 1/3 is less than because that's what my brain said. When I'm reading the sentence, that cannot be the symbol I use because it has 1/2 written first. And I read sentences left to right. So 1/2 is greater than 1/3. If 1/3 was on the left side, I could say 1/3 is less than 1/2. And those are the same types of statements. Same with the second one. 1/5 is less than 3/6. But we could also do the opposite of that, where we say that 3/6 is greater than 1/5. Either way, we're saying the same thing. Which one is larger? Which one is smaller? And then let's do this one. We have 2/7 and 4/8. So 2/7, when I divide, remember top divided by bottom, that fraction bar is just division. 0.2, where 2 is repeating. And then here, I'm going to do the same thing. 4 divided by 8, that fraction bar is just dividing. That's going to give us 0.5. Even though that 2 is going on forever, 2 cents is definitely always less than 5 cents. So I know that this is going to be the larger one. You've probably heard them say that these are alligators and the alligators are eating the larger number. I don't mind if that's how you know how to sort through them, but I need you to know that this is the less than sign and this is the greater than sign. So that's how we would do that here. The only thing I also need to add is when we are comparing negative numbers, yes, I know, negative numbers, they're back to haunt us. The bigger the negative number is, the less it's actually worth. Think about it like this. When I owe you $3 versus if I owe you $5, how much difference is that? About 2, right? but I'm going to have to give you $2 extra if I'm in debt $5 rather than if I was in debt $3. So the bigger the negative number, the less money I actually have in my possession because it's all going to have to go to you anyhow. The bigger the negative number, the less it's worth. So let's talk about it. So this is negative 0.5. Remember, we got to keep that negative, and I just divided. I'm going to divide again here. So it's negative 0.3 repeating. But even though this is a bigger number, it's a negative number, so it's worth less. So that negative 0.3 repeating is actually larger. So negative 0.5 is less than negative 0.3 repeating. Only when it's negative does this apply. Let's try it here. So I have negative 3 and negative 2. Negative 3 is a larger number than negative 2, and because it's negative, the larger the negative number, the less it's worth. So negative 2 is worth more. And then here, I have negative 1 and negative 5. Negative 5 is a larger negative number, and the larger the negative number, the less it's worth. So negative 1 is bigger. I hope this helps when we're talking about comparing rational numbers. And when we are talking about ordering them, just compare all of your numbers and figure out which one is the least to the greatest and read those words very carefully. Thank you so much. Hit the like button if you'd like more content like this. And if you have any other questions, ask your math teacher. Thank you so much. Bye-bye.